So in this video, we're going to look at some applications of the definite integral for business. So the first thing we're going to talk about are the demand curves and supply curves. So the first one is the demand curve. That gives a relationship between the quantity sold and the unit price of a commodity. It says that to sell X units, the price must be set at F of X dollars per unit. So for most commodities, selling larger quantity requires lowering of price. As a result, the demand curves generally decrease. Think about this in terms of when people buy in bulk, they generally expect the price for each item to be less than if they just bought a single item, which is why they often buy in bulk or go to a place like Costco because it's cheaper per each single item if you buy in bulk. And that's the idea of the demand curve. So the demand curve is always going to be decreasing, or most of the time is decreasing, and all the ones we will deal with are decreasing because as the number of quantities are sold, the price of it is going to decrease. Now for the demand curve, we call it usually D of X is our demand curve. Represents the demand curve. And if we draw a graph of it, we have some type of decreasing function. It could be linear. It could be like sometimes they look like this. For this, on the x-axis, is often called Q, and Q again stands for the quantity or the number of units sold, and so that's represented by Q, and that's the x value. And then the y is often called, the y-axis is called P for price, and that's equal to F of X or the y value for our graphs. And these are our demand curves. The other curve we're interested in is the supply curve. So the supply curve tells us how many producers will sell the product at a particular price. More producers are willing to sell goods if a higher price is offered. Thus, the supply curve is usually increasing. So if producers are not going to get much for a good, then not as many companies are willing to sell it. But if the prices are increasing and the demand is increasing, then generally more companies will be willing to sell those items. And then the price is increasing and the quantity is increasing. So it works the same way. In this case, we use S of X to represent the supply curve. And on the x-axis, again, is Q, which stands for the quantity. And on the y-axis, again, is price, which stands for F of X. And again, that will generally be an increasing function. So we often graph the supply curve and the demand curve on the same axis. And we want to find where they intersect, which is called the point of equilibrium, or the equilibrium point. So the equilibrium point is the point where the supply curve and the demand curve intersect. And this is the price and quantity where consumers are willing to buy and suppliers are willing to sell. And this is where prices become stable. So this is kind of the ideal place where we want the price of items to be in order for the prices to be stable, and then that we get a decent amount of customers buying it and a decent amount of producers willing to sell it. So the point of equilibrium is often indicated by Q star, P star. Q again is for the quantity, and that's the X value. And P stands for the price, and that's the Y value. And the stars indicate the equilibrium point. Again, it depends on the textbook or the website that you're using. Some just say capital Q, capital P. Some say Q star, P star, but most of the time for this class, we use the lowercase Q star and the lowercase P star. And that's where the supply curve and the demand curve are equal, that point of equilibrium. So let's look at an example. Let X be the number of items. D of X, which again is my demand curve, is 4,200 over the square root of X. And S of X equals 4 the square root of X. And S of X is the supply curve. Find the equilibrium quantity. So sometimes they say equilibrium quantity. Generally, if they ask for that, they just want the X value of the equilibrium point. You don't need to find the Y value. We'll still find both just to show you how to do it. So for the equilibrium quantity or the equilibrium point, what we need to figure out is where D of X is equal to S of X. So we would set 4,200 over the square root of X equal to 4 the square root of X. Okay. And this is how we solve it algebraically. If you want to solve it graphically, you can put them into your Y1 and Y2 and then graph them. Now, I will tell you, like, if you hit Zoom standard, for most of these, the prices are pretty high. And if you just do that, you're not going to see both curves. So you need to see two curves and where they intersect. So you will have to play around with the window a lot. So if you don't like the algebra part, you're welcome to do that. But some of the questions will ask you to actually graph it. And so you can always do the algebra part first to figure out your window and then graph it and sketch it from there. One thing you could do to try to see both a little bit more is hit Zoom and then go to fit number 0, but it's going to be pretty far zoomed out and you still can't see where they intersect, but you can at least see both curves now. So I definitely need like my X value, the X max, to be higher to see where they intersect. So I don't know, let's try like 5,000 just to hopefully be high enough. And now it's like really zoomed out. So I definitely have a lot of space up here, which means I don't need my Y max to be so high. So let's try that as 5,000. Again, I'm just kind of guessing and checking and seeing if these work. I can kind of see it. I don't need to be that high again. So let's go 1,000 for the Y max. There we go. Now I can see it better. So again, it's literally guessing and checking to figure that out. So if you're doing it graphically, you can sketch the two curves and then again, go to second calc, number 5 intersect, move your cursor over to where they intersect or close to where they intersect. You don't have to be right on it. And then hit enter until you see that intersection, which is 3 times. So it's 1,050 and 129.61. So that would be your equilibrium. Your P star in this case would be that 1,050 and the Q star would be the 129.61 if I do 2 decimal places. Okay, so this would be the point of equilibrium. The equilibrium quantity, you just give that P value. That's how you do it graphically. Algebraically, you would set these equal and solve it. So to solve this, you would multiply, because we're dividing by the square root of X, I need to get that out of the denominator first. So I multiply both sides by the square root of X. These reduce to 1, so they cancel. And then I get the square root of X times the square root of X, which is just X. And then I can divide by 4. And that again gives me the 1,050. Okay, so this is the X, which is the, I had this backwards, sorry. This is the Q star. Let me fix that here. So this Q star is the X value. P star is the Y value. Again, because price is on the y-axis and the quantity, which is the x-axis. So this is the x value. And then if you were doing algebraically to find the y value, you can plug it into either one. I mean, you could plug it into both to check, but you can plug it into either d of x, the original, so that was again 4,200 over the square root of x. So that would be 4,200 over the square root of 1,050. And you can put that in your calculator. And that gives me that 129.61. And you can also try it by plugging into the supply clever. They should be the same because we're saying that they're equal. So that would be 4 the square root of x. So that would be 4 the square root of the 1,050. Which again, just to verify, also gives me 129.61. Okay, so these are your, again, P stars, they're the Y value. So the equilibrium point we would say is 1,050. And 129.61. And again, if they just want the equilibrium quantity, then we would say it's 1,050. If you are doing it just graphically, make sure you do sketches on them. Some of the ones will be required and they'll be giving you a graph, and I'll do a few more examples like that in a different video.